Hi, welcome to Unit 6 of SAT Math, Passport to Advanced Math, Part 3. We're going to start off today by talking about linear and exponential growth. So linear growth is a constant slope. Make sure you check both variables, and they have an exponent of 1. Exponential growth is a constant multiplier, so every time it either doubles or triples at each time step. A variable is raised to something other than the power of 1. So let's look at question 1. We have this table here. Jim recently opened a new clothing store. In the table above, the relationship between the number of customers C and the weeks since opening W is shown. Which of the following correctly depicts the relationship of C with respect to W? So let's look at what we have here. So at the first one, we have 30. At the second, we have 60. So the difference between here is 30. Or, what will actually make it more clear is if we called it multiplied by 2, so times 2. And then from 60 to 120, we see that this is also times 2. 120 to 140, this is also times 2. And as we go on, we see each step is times 2. So our immediate reaction would be to say, oh, this is exponential. Each time it doubles. However, let's be careful here. We see that the time steps going forward are also being multiplied by 2. So the ones that we're seeing are not actually 1, 2, 3, 4, 5. It's actually 1, 2, 4, 8, 16, and 32. So these are also being multiplied by 2. Which is why this relationship is actually not exponential, but instead actually linear, because both variables are going up by a multiple of 2 each time. So in this case, what we're going to pick is one that's linear, and we see that the one that matches up better is answer choice A, because it goes up by approximately 30 per week, because we see from week 1 to week 2, it goes up by 30. Okay, question 2. Which of the following would give George an exponential growth of money in a savings account? So let's go through these options. First, we have every year George adds 4% of the initial savings to the value of the account. So unfortunately, this is not an exponential growth. It's because he's doing 4% of just the initial savings. So B, every year George adds 2% of the initial savings and $200 to the value of the account. Again, similarly to A, what we're going to be adding is the same amount every year. So this is going to be linear growth. Option C says every year George adds 2% of the current value of the account to a current value to the value of the account. This is actually exponential because we're adding 2% of our new amount each year. So that 2% gets bigger and bigger and bigger. So we're going to pick C. But let's take a look at D as well to make sure. D says every year George adds $200 to the value of the account. Again, very similarly to A and B, this is going to be linear growth because you add the same amount every year. Okay, question 3. Question 3 says after 24 hours, 30% of a 25 milligram dose of a new antibiotic remains in the body. Which of the functions M models the amount of antibiotic in milligrams that remains in the body after 8 hours? So big thing here we see, we start off with 30%, and that 30% is of a 25 milligram dose, so you have to be careful here. So what that means is our initial condition that we're starting off with is going to have 25 as our initial, like this, so we can cross out A, but then 30% of that, so that 30% is here, so we can cross out D. So now we're just left with B and C. Going on now, we see that after 24 hours, this occurs. So that means that we have to take each of this 30% at every 24 hours. And just to make sure we have the right time step, we are in H hours. So our time step is hours, which means that we just need to divide H by 24 so that we apply that 30% every 24 hours, which means we're looking at answer choice B for this one. Okay, question 4. Wilson put the $450 he earned from a summer job into an account and will use it to pay for school expenses. He withdraws 10% of the remaining balance each month to pay for part of his living expenses. Which of the following functions models the balance B of Wilson's money in dollars M months after he started school? Great. So the first thing here, we see that he is going to withdraw 10% of the remaining balance, which means this is exponential growth. So first thing we can do, we can remove the linear growth ones, which we see is C and D. So in this case, we're left with A and B. Now what we're doing is we're withdrawing 10%. So what's happening is we're decreasing the balance, which means that this is not 110% of the balance each month, but 0.9 or 90% of the balance each month, which is why we see that in B, we're going to be decreasing because as the months go on, we're going to be decreasing the total balance B. So in this case, B is our correct answer. Question 5. Amy's weekly income is $500. At the end of every week, after receiving her paycheck, she gives 25% of what's in her bank account to her younger sister. If the current amount in her bank account is $1,250, the next time she will pay her sister and receive income is next week. How much money will her sister receive over the next 2 weeks? So let's see. Amy is going to start off with $1,250. At the end of the first week, she'll first receive her paycheck, so she'll be $1,750, and then she'll give 25% of this to her sister, which means she's going to give $437.50 to her sister. So this is the first amount that she gives her sister. So this is week 1. Week 2, after we subtract this from $1,750, we're going to be left with $1,312.50. Now with the $500 paycheck she receives, she gets $1,812.50 in her bank account, meaning that 25% of that she'll give to her sister, which is $453.13. Excuse me, 13. So this is what she gives her sister that second week. So now what she's going to give her sister is the sum of these two combined. So her sister's going to end up with a total of $890.63. Okay, question 6. Which of the following represents all solutions x, y to the system of equations shown below? So with this system of equations, what we first want to do is we see we have a y over here and a y over here. So let's go ahead and set these two equations equal to one another. We have x squared plus 2 is equal to 3x squared minus 2x minus 2. So now, so that we get a 0 on one side, let's go ahead and subtract x squared and subtract 2 from both sides. So on the left-hand side, we're just left with 0. On the right-hand side, we're left with 2x squared minus 2x minus 4. So now we can go ahead and divide all of this by 2. So we end up with x squared minus x minus 2, which means we can factor this as x minus 2, x plus 1. So our solutions for x are going to be 2 and -1. So now plugging these values back in, we see these correlate with y values of 6 and 3. So our answer is going to be 2, 6, and -1, 3. So answer choice D. Okay, question 7. If z to the j squared over z to the k squared is equal to z to the 20th power, and z is greater than 1, and j plus k is equal to 2, what is the value of j minus k? So this one doesn't seem quite straightforward, but let's employ some of our exponent rules, see if we can simplify this equation we're given here. So first thing we see, with both the numerator and the denominator having a base of z, we can go ahead and rewrite the left-hand side as z to the j squared minus k squared. And this is going to be equal to z to the 20th. So now we can actually get rid of the bases, so we have just j squared minus k squared is equal to 20. This way, we can factor this out, and we'll end up with j minus k times j plus k is equal to 20. And since we know j plus k is equal to 2, this just means that j minus k times 2 is equal to 20. So j minus k is just equal to 10. So our answer is A. 8. Two equations intersect in the yz plane. The first equation is the parabola with the formula z equals y minus 5 squared, and the second equation is given to be z equals 49. If these equations intersect at the points j and k, what is the length of jk? So here in this case, we see that z is equal to 49 and z is equal to y minus 5 squared. So let's go ahead and just set those equal to one another. So now we have 49 equals y minus 5 squared. So what we can do is we can go ahead and square root both sides. Make sure we're careful with this. Once you square root both sides, the left-hand side can be plus minus 7, and the right-hand side is going to be just y minus 5. So now, if we go ahead and add 5 to both sides, being very careful how we add 5 to both sides, we now are left with y is equal to plus 5, plus 7, plus 5, which is equal to 12, or negative 7 plus 5, which is just negative 2. So in this case, our points are going to be at 12 and negative 2, which means the distance between these two is going to be 14a. Question 9. Bill throws a baseball across the field. The height of the ball off the ground is given by that equation, where y represents feet and x represents time in seconds. At the same time that Bill throws the ball, a rocket at Bill's feet is released and rises at a rate of 2 feet per second. Assuming the rocket and the ball are traveling at the same speed, the rocket and ball are the rocket and the ball ever at the same height? If so, what height? So what we can do here is we can go ahead and take those equations once again, like we saw before, and set them equal to one another. So in this case, we'll see that we have 2x, since it's 2 feet per second, and x is our time in seconds, is equal to negative x squared plus 3x plus 6. Now, of course, subtracting 2x from both sides, we're left with 0 is equal to negative x squared plus x plus 6. So now dividing both sides by -1, we're left with 0 is equal to x squared minus x minus 6, which of course we can factor to x minus 3 times x plus 2. So that means at the times x equals 3 and x equals -2, these two will be at the same height. However, -2 seconds doesn't really make sense, so we're going to say that they are the same height at 3 seconds, which if we plug, so be careful not to pick C, but if we plug this back into our equations, well, y equals 2x, we'll see that this will occur at 6 feet, or D. Okay, polynomial factors and graphs. Zeros and x-intercepts are values for which y equals 0. So, question 10. Given the polynomial function y defined above, what are its zeros? So first thing here, the zeros, like we just read, are the x-intercepts, or when y equals 0. So let's go ahead and set y equal to 0. We have 0 is equal to 4x cubed plus 12x squared minus 16x. So this case, the easiest way to simplify this would be to divide both sides by 4 first. So we're just left with 0 on the left, and then x cubed plus 3x minus 4x. Sorry, this is 3x squared minus 4x. So now we can go ahead and do some factoring. Let's factor out an x first. So we're left with x times x squared plus 3x minus 4. And then factoring the inside, we get x plus 4 times x minus 1. This way we know our values for x are going to be 0, -4, and 1. 0, -4, and 1 gives us answer choice D. Okay, question 11. Question 11 says, assuming that the polynomial has zeros at -3, 1, and 0, which of the following could be the equation of the polynomial? So, kind of like working in reverse from question 10, we see that if we have a polynomial with zeros at -3, 1, and 0, that means we can rebuild it up using the factors. The factors being x plus 3, x minus 1, and just x. This way, we have now basically built our polynomial, and we'll just go ahead and distribute out. So we have x squared plus 2x minus 3 times x, which gives us x cubed plus 2x squared minus 3x. So in this case, we're left with answer choice B. Okay, question 12. Which of the following equations could represent the graph above in the xy plane? So we're given this arbitrary graph. There's not many specific labels on it, but there's some cool, key features to note. It is symmetrical about the y-axis. So, and we have 1, 0 on above, 1, 0 greater than 0, and 1, 0 less than 0. So, which one could they be? Let's look at option 1 here first. We see that its roots are at +5 and -5, which, given that we don't know the scale of this graph, this could potentially be true. So we're going to hold on to that one. The next one, we have x minus 4 squared. So what is x minus 4 squared? That's just the same thing as x minus 4 times x minus 4, which means there's only one distinct root, which means it would look something more like this. It'd be just touching the x-axis. So that can't be right. So let's go ahead and look at option 3, because this is wrong. This is x plus 1 and x minus 10, which means our roots are going to be at -1 and -10. However, we see this graph has a positive root and a negative root, which means that this also can't be correct, so we're just left with only option A. Okay, question 13. A mystery function P is characterized by having 3 distinct zeros. Which of the following graphs could be function P? Like we kind of saw earlier, a distinct zero means it either touches or crosses the x-axis. So if we have 3 distinct ones, it should either cross or touch the x-axis at 3 different places. So A we see only touches once, so that can't be right. C touches at 1, 2, 3, 4, 5, which also can't be right. B touches at 1, 2, 3, and 4, so that can't be right. And thankfully, D touches at 1, 2, and 3, so we can pick answer choice D. Question 14. Which of the following functions could represent the graph above in the xy plane where y equals f of x? So first thing to note here is that this graph has 3 solutions, or 3 roots, which means that we can immediately eliminate A and C because both of these are quadratic, meaning that they can only have a maximum of 2 distinct roots. So now looking at these 3 roots, we see that 2 of them are negative and 1 of them is 0, which means that this can only be B since there's a negative here in D. Okay, question 15. 2 consecutive odd integers are squared and subtracted from each other to yield 188. Of the 2 numbers, what is the value of the smaller one? So here, like we remember seeing in previous lessons, two consecutive odd integers can be represented as x and x plus 2. To find the difference of the squares of these two, we square both of them, x plus 2 squared, and then we subtract them, so minus x squared. And this should equal 188. Now, distributing this out, we see that we have x squared plus 4x plus 4 minus x squared equals 188. And then we can cancel out the x squared, so we're just left with 4x plus 4 is equal to 188. Simplifying this a little bit, we see 4x is equal to 184, which leaves us with x is equal to 46. So our answer is C. Okay, nonlinear equation graphs. An asymptote is a point at which the graph is undefined, and this usually occurs because we end up dividing by 0 somehow. So usually when you see a fraction, be careful for asymptotes. And graphically, an asymptote may look something like this, if you have the x and y, where a graph kind of just shoots up here, and then it kind of ends up never touching some line like this, where that would be our asymptote. So, question 16. We see which of the following equations does not have a y value that is less than 1. So, this one we should go through all the answers just to double check that we're right. Looking at answer choice A, we see the absolute value here, which makes it tempting for us because it means that, oh, absolute value, it can never be less than 0. However, we're taking the absolute value and then subtracting 3. So if x is equal to 0, y would be negative 3. So that wouldn't work. So we can cross out A. B is a similar situation. X squared, oh, that can never be less than 0. However, you're subtracting 3 after squaring x. So if x is equal to 0, again, y would be equal to negative 3, and that's not okay. So B is not good. So C looks promising because you're squaring it at the end. You're subtracting 3 and then squaring it. So it can be negative inside, x can be anything, x minus 3 can be anything, and then once you square it, it'll always be positive, which is why answer choice C is going to be correct. But let's just check answer choice D. Answer choice D is a similar idea as answer choice B. Regardless of what x is, you're always going to subtract 3, so it can be negative. Also, because it's cubed, it can already be negative, right? So answer choice D is incorrect. Question 17. The function given results in a parabola with vertex a comma b. If z is an unknown constant, which of the following represents the value of b? So this one's a little tricky. It requires a couple of different steps. First thing to note when we look at the equation, we see that z is just a constant. So the parabola that we're given is actually still very similar to what we just have here. So this parabola here, let's break it down and see what we're dealing with. If we factor this out, we see it's going to be x minus 5 times x plus 3, which means we have roots at 5 and negative 3. So if we have a vertex AB, even though we're scaling it with z, it's going to scale symmetrically, which means that the vertex itself is still going to be halfway between 5 and negative 3, which means that it's going to have an a value of 1. So now we can plug 1 into this equation now. So we have y equals z times 1 squared minus 2 times 1 minus 15. And we see that we end up with 1 minus 2, negative 1 minus 15, negative 16. So this gives us negative 16z for the value of b, the y value at the vertex. So A is our answer. Great. Next, we're looking at function notation. F of x equal to something is the same thing as saying y equals that same function. So wherever you plug in for f of x, plug in for every x in the equation, and it works very similarly to all the equations we've seen thus far. So 18. For the function y above, k is a constant, and y of 4 equals negative 6, which means for every x value we sub in 4. What is the value of y of negative 4? So first things we see here, from this, we can tell that we have a point 4 comma negative 6. So let's plug that in. So we have negative 6 is equal to k times 4 squared plus 26. Fairly simple. Let's go ahead and simplify this. We end up with negative 6 equals 16k plus 26. And then if we subtract 26 from both sides, we end up with negative 32 equals 16k. We get k equals negative 2. So now that we know that k equals negative 2, we can go ahead and solve for f of negative 4. So that just means we're looking for f of negative 4 being set equal to negative 2 times negative 4 squared plus 26. And doing a little bit of math here, we see that this gives us negative 6. So our answer is going to be A. Question 19. Certain values of a polynomial y of x are defined above. Which of the following is a factor of y? So looking at this function here, we see that we are given a couple of different values, and we are looking for which of the following is a factor of y, which means it is also going to be a 0 of y. So we see that whatever these values is, we need y to be equal to that when x equals 13, 6, 1, or 4. So looking at this table here, we see that y actually ends up being 0 right here, which means at that point we have x is equal to 1. So our factor would actually be x minus 1, so that we have a factor of x equal positive 1. So we can select answer choice C, x minus 1. Okay, let's move on to complex numbers. So square roots of negative numbers are called imaginary numbers. And square root of negative 1 is called I. This is just the notation we use, and these are the complex numbers. So I is equal to square root of negative 1. So I to the first power, just like any other number, is just I. I squared, however, is negative 1. Because I is equal to square root of negative 1, I squared is just negative 1. And then I to the third is negative I to the fourth is 1, and then I to the fifth is just I again. So this I moves in cycles of 4 with respect to the power. So example, what is the value of 4 plus 2i squared? You can see we can break this out just like any other distribution or FOIL. 4 times plus 2i times 4 plus 2i, distribute it out, and then just make sure you're careful. The I here is an I squared, so that becomes negative 1, as you see happens right here. And that allows us to simplify it back down to just a real component and an imaginary component. Okay, question 20. For I equals square root of negative 1, what is the sum 2 minus 4i plus 6 plus 6i? So here, when we're adding them together, make sure we just add the real components and we add the imaginary components. So the real components are 2 and 6, so that gives us 8. The imaginary components are negative 4i and positive 6i, which gives us plus 2i, so that leaves us with answer choice A. Question 21. Which of the following is equivalent to 3 minus 2i over 3 plus i, with, of course, I equal to the square root of negative 1. So the trick here is that we have I in the numerator and denominator, and we don't really know what to do with it. However, it works similarly as if you were to treat I as any other variable. So let's go ahead and get rid of that I in the denominator so it's easier to evaluate. So we multiply 3 minus 2i over 3 plus I by the conjugate of the denominator, which is 3 minus I multiplied by this over 3 minus I. This way, let's go ahead and simplify it. So let's FOIL out the numerator. So that's 9 minus 3i minus 6i plus 2i squared. And that is going to be over 9 plus 3i minus 3i cancels because we did the conjugate minus I squared. So now, this we simplify again. We know that I squared, both here and here, are both equal to negative 1. So this can be 9 minus 2, which gives us 7 minus 9i over 9 minus negative 1 plus 1 over 10. So this way we see we have 7 tenths minus 9 tenths I, which gives us answer choice C.